There is a device sitting on a rooftop in the Netherlands right now that is roughly the size of a large houseplant. You could fit it in the back seat of your car. You could carry it up a flight of stairs by yourself, and according to the people who built it, it generates enough electricity to power an entire home for an entire year. Not to supplement your electricity, not to take the edge off your bill, to replace it. And it does this in complete silence, without a planning permit in most countries, without a contractor, and for a price that is less than most people spend on a single month of European electricity. This is not a solar panel. This is not a battery subscription service. This is not a concept rendering that might ship in 5 years. This is real. It is called the Blade X1, and it was built by a Dutch startup named Cell Technologies. And if it does what its inventors say it does, your relationship with your electricity provider is about to change permanently. Let me be brutally clear about what is happening to household energy right now. Your bill is not climbing because of bad luck. It is climbing because of a structure that was designed to keep you dependent. The average EU household paid roughly 1,400 euros for electricity in 2025. In Germany, it was over 2,000. In the UK, households hit £1,500 under the October price cap. And in the United States, electricity rates have risen 17% in just 4 years, from 15 cents per kilowatt hour in 2022 to nearly 18 cents today. With no structural reason for that trend to reverse. Data centers are consuming more grid power than entire cities. Governments are adding network charges, taxes, and green levies on top of an already climbing base rate. Every year, you stay connected to the grid the way you currently are, you're paying more for the same service. And the utility company knows you have nowhere else to go. That has been the trap. And the reason the trap has worked for so long is simple. The alternatives have been either too expensive, too ugly, too loud, or too large to realistically fit into the life of an ordinary family living in an ordinary house. A standard residential wind turbine with enough capacity to meaningfully replace your grid consumption costs between $15,000 and $175,000 installed. It requires a tower. It requires planning permission. It requires a structural engineer in most municipalities. It requires your neighbors to agree to look at it. And it produces noise that transmits through your walls while it does it. The turbine that could actually help you has, until now, been completely unreachable for almost everyone. Enter Cell Technologies. Founded by two Dutch engineers named Francois Huybrechts and Marcel Nachtgeboren, this is a company that looked at every limitation of small residential wind energy and decided to solve all of them simultaneously. What they built is so compact, so quiet, and so radically different in its underlying physics that when they first presented it publicly, the energy experts in the room told them it was impossible, that it violated the laws of physics, that a machine this small simply could not produce this much power. And here is the thing. The experts were right about the physics. They were just wrong about the design. There is a law in aerodynamics called Betz's law, formulated in 1919 by German physicist Albert Betz. It states that no wind turbine, regardless of how cleverly it is designed, can capture more than 59.3% of the kinetic energy in the wind passing through it. This is not a regulatory limit. It is not a manufacturing constraint. It is a law of physics derived from the conservation of momentum, and it applies to every turbine ever built. It is the fundamental reason why small turbines, which have a tiny swept area and therefore pass very little air through their blades, have always produced disappointing amounts of power. You cannot get around Betz's law. What Huybrechts and Nachtgeboren figured out is that you do not have to. The Blade X1 does not violate Betz's law, it uses it twice. And that single insight is the engineering breakthrough at the center of everything. Here is how it works. On top of the turbine sits a rotating plastic hood. It moves freely with the wind direction the same way a weather vane does, automatically orienting itself to face the prevailing breeze. But this hood is not decorative. It has a specific aerodynamic function. As wind enters the front of the turbine and passes through the blades, the hood prevents it from simply escaping out the back. Instead, it redirects that exiting air and feeds it back through the blade assembly a second time. The same parcel of wind passes through the turbine twice. Betz's law still applies on each individual pass, but because the wind goes around twice, the turbine extracts energy from it twice. Two applications of a 59.3% efficiency limit stacked extract significantly more total energy than one. And then there is the transmission system. This is the second problem that has killed every previous small residential turbine. Even when a compact turbine captures reasonable wind energy, the blades turn too slowly to spin a generator efficiently. At low wind speeds and small blade diameters, the rotational force available is simply not enough to overcome the resistance of a generator. Cell technologies solve this the same way a car's gearbox solves the problem of engine torque at low speed. Inside the Blade X1, the rotating blades drive a large gear. That gear connects to progressively smaller gears in sequence, each one spinning faster than the last, until the final stage is turning fast enough to drive the generator at full efficiency. By wind force 4 on the Beaufort scale, which is a gentle breeze you would barely notice walking down the street, the Blade X1 is already generating at full power. And if the wind climbs high enough to risk damage, the control software automatically reduces turbine speed to protect the system. There are no mechanical brakes, no wearing components exposed to the elements, just software managing a sealed mechanical system that runs quietly enough that your neighbors will not know it is there. The numbers that come out of all of this are the part that requires a second read. The Blade X1 stands 1.40 meters tall, 60 centimeters wide. You could stand it next to your front door, and it would be shorter than your door frame. And in average wind conditions, it produces between 2,500 and 3,000 kilowatt hours of electricity per year. That is the full annual electricity consumption of an average Dutch household. In practical terms, for a European homeowner paying the average rate of 29 cents per kilowatt hour, 3,000 kilowatt hours per year represents roughly 870 euros of electricity. Every year, gone from your bill, not reduced, gone. And the device that produces it costs approximately 2,500 euros before installation. At current European electricity prices, you're looking at a payback period of under 4 years on hardware alone. After that, the electricity it generates costs you nothing. The wind does not send invoices, and this is where the personal outcome for your home becomes very concrete. The average European household electricity bill is climbing at roughly 3% per year, even in stable price environments, and has been climbing far faster than that across the recent energy crisis years. Every year your bill goes up, the value of owning a device that offsets it goes up with it. A homeowner who installs a Blade X1 today and pays off the hardware cost within 4 years is then generating free electricity for the remaining lifespan of the device. And because the system has no exposed mechanical brakes, no weather-damaged mirrors, no chemical degradation, and no cells losing efficiency over time, the projected service life of the design is significantly longer than the payback period. You are not buying a gadget. You are buying a financial position against a utility company that has been raising your prices every year for a decade and has no incentive to stop. You pay 2,500 euros once. It generates roughly 870 euros worth of electricity every year at current European rates. In about 3 years, you've broken even. After that, the electricity is free. Meanwhile, your neighbor is still paying 1,400 euros a year to the utility company every year forever, while that bill keeps going up. Cell Technologies plans to produce 60,000 units per year out of their facility in Etten-Leur in the Netherlands. The turbine can be mounted on a flat roof, bolted to the side of a building on a pole, placed in a garden, or installed on a balcony. It operates in silence. It does not require planning permission in most European jurisdictions. It captures wind from every direction automatically because the hood rotates to face whatever way the wind is blowing. You do not need to know which way the prevailing wind runs on your street. The device figures that out for itself. Now, the honest caveat, because there always is one. The Blade X1 is a young product from a startup that is still scaling production. The 2,500 to 3,000 kilowatt-hour output figure is the company's claimed performance under favorable conditions, and independent third-party certification testing is still underway. The actual output you experience will depend directly on how much wind your specific location receives. A home in a sheltered valley in southern Germany will see different results than a house on the Dutch coast. What is not in dispute is the underlying engineering. The double-pass wind capture mechanism is patented, the geared transmission principle is mechanically sound, and the fundamental physics of why this design outperforms every previous small turbine at this scale are well established. The question is not whether the machine works. The question is whether it works well enough at your address to justify the investment. And the only way to answer that is to look at your local wind data, which most national meteorological services publish for free, and calculate the math yourself. But here is the framing that matters for any homeowner making this decision in 2026. You are not comparing a €2,500 turbine against free electricity from the grid. You are comparing it against a utility bill that is structurally committed to rising every year for the rest of the time you live in that house. The question is not whether the Blade X1 is perfect. The question is whether it is better than doing nothing. And for a growing number of homes in windy locations across Europe and beyond, the answer to that question is becoming very difficult to argue against. If you want to stay ahead of what is happening in energy independence for ordinary homes, subscribing is the most direct way to make sure you see it when we cover it. And if you want to understand the physics of why small turbines have historically failed and how designs like this one get around those limits, our video on the engineering of residential wind is where that conversation goes deeper.